All right, in this lesson, we will be reviewing sine, cosine, and tangent, and we'll look specifically at how those three trig functions apply to a circle. Remember, we can use these three functions to measure distances on a graph, not just angles in a triangle. Before we get into that, at the top, this is mostly just a reminder for you all because I still hear some people saying, sin for sine and cos for cosine. So just as a reminder, these are abbreviations, and I'm going to write their actual names right next to each just to make sure we're all using the same language. Okay, so remember SIN is sine, COS is cosine, and TAN is tangent. Now, again, we've already reviewed this. You all should remember this, but remember on a right triangle, we have these three trig functions that represent ratios on a triangle. Specifically, it's one side of a right triangle divided by another side of a right triangle. And this acronym SOHCAHTOA helps us remember this. All right. So in sine, for example, S, that is equal to the opposite side over the hypotenuse, or the opposite side divided by the hypotenuse. We can follow a similar format with cosine and with tangent. So I'm going to write those ratios over here off to the right, just again as a review. So the sine of some angle is going to be equal to the opposite side divided by the hypotenuse. The cosine is the adjacent side divided by the hypotenuse, and the tangent is the opposite side over the adjacent side. And just again, real quick for review's sake, the opposite side refers to the only side the angle is not touching. The adjacent side is the side that the angle is touching, and the hypotenuse is always the slanted side. All right, very good. Now, let's apply this to a circle on a graph. So it says, given an angle in standard position and a circle centered at the origin, there is a point P where the terminal ray intersects the circle. So that's what we have drawn here. We have our starting ray, which is always in the positive x direction, and then we have a terminal ray on the circle, and that point is labeled P. It says, using SOHCAHTOA, we can find the value of sine, cosine, and tangent of the angle. So once again, I want to think through if I were to draw a triangle inside this circle, just like that. Let me use a different color so that it stands out. There we go. If I were to draw a triangle in this circle, first of all, you could see that it is a right triangle. We can see that the right triangle has that same angle theta, and we can use this triangle to figure out what the sine, the cosine, and the tangent would be on that graph. All right, so when I'm looking at sine, remember it says sine is opposite over hypotenuse. So the opposite side, that would be this side right here. This is the vertical displacement of P from the x-axis. In other words, it's the distance from the x-axis all the way up to P. Well, we know that the vertical coordinate, that is the y-coordinate. All right? And then I can say that we're going to divide that by the distance between the origin and point P. That would be this slanted side here. That is the hypotenuse. Well, on a circle, the hypotenuse is just the radius of a circle. So I can go ahead and label that R. In which case, sine is going to become y divided by R. Now, we've never seen this before. In the last couple videos, we were talking about the unit circle. And in the unit circle, the radius is 1. So this ends up being y divided by 1. That's why in the last two videos, sine theta just equaled y. But if the radius wasn't 1, then we would do y divided by r. Okay, we can do something very similar for cosine. Cosine is this adjacent side right here. It is the horizontal displacement of P from the y-axis. So this horizontal distance, we know that that is the x-coordinate. So now I know cosine is equal to x divided by the hypotenuse, which is of course just r. And then finally, I can do this for the tangent angle. I'm going to do the opposite side over the adjacent side. All right. So when I go to write my fraction, I'm going to look at the opposite side of this angle, which is the y distance. Then I'm going to divide that by the adjacent side of this angle, which is the x distance. So I end up with y over x. And of course, we learned in our last video, all right, that y is the sine value and cosine is the x value. However, this is a little different, right? Because in the last video, we learned about the unit circle and r was 1. So if I were to rearrange this cosine function so that it said x equals, okay, all I would do is multiply this r over to the other side. So x is r times the cosine of theta. I'm going to put a box around it because that's pretty important. And if I do the same thing for my sine function, if I rearrange it for y, this is going to be y is equal to r times the sine of theta. I'm going to put a box around that. So now I know if y is equal to r sine theta and x is equal to r cosine theta, then that means the tangent must be r sine theta divided by r cosine theta. And the r's cancel. So just like in the unit circle, whether we're on the unit circle with radius 1 or not, tangent is always equal to sine divided by cosine. All right, on the back, let's try some problems with this. So it says for this first part, each figure below gives a circle in the xy plane with the center at the origin and an angle theta in standard position. Find the value of each expression. All right, so I'm going to show you guys how to do sine, and then you guys can probably work through cosine and tangent on your own. So sine, we just learned, is going to equal the y-coordinate divided by the radius of the circle. I know the y-coordinate already. In this problem, it was given to me. The y-coordinate is 1. However, I do not yet know the radius of the circle. So if I were to imagine for just a moment that this is a right triangle, then I can very easily figure out what r is if I know that this distance is 3 units and this distance is 1 units. Yes, I know the x-coordinate says -3, but the negative just tells us what direction we're going. That just tells us we're going backwards. You can't have a negative distance, so this is really 3 units, okay? So now, if I know 2 legs of a right triangle, and I want to find the slanted side, well, that's just Pythagorean theorem, okay? So I know that 1 squared plus 3 squared needs to equal r squared. And 1 squared is 1, 3 squared is 9. So that means r squared is 10. If I were to figure out what r is, I would take the square root of both sides, and I would get 10, or sorry, the square root of 10 is equal to the radius. Okay, so now going back to my function, the sine value is going to be equal to the y-coordinate, which is 1. So remember, this is y, this is x. So I have 1 divided by the square root of 10. And normally we don't like to leave roots in the bottom of fractions. So what we do is we multiply on the top and the bottom by root 10 to get the root out of the denominator. So root 10 times root 10, that's 10. And then root 10 times 1, that's root 10. So now I know the sine of this angle is root 10 over 10. Okay, if I were you, I would go ahead and pause the video, see if you can do cosine and tangent, and I will give you the answers to those in 5, 4, 3, 2. Okay, if you look at cosine, it was x over r. The x coordinate is -3, and the radius is √10. So, of course, we don't like the radical in the bottom, so we get it out of there, and we have -3 √10 over 10. And then the tangent value is just y over x. That is 1 over -3, so we get -1/3. Okay, very good. If we look at this next problem, it is very similar. So now we have an angle in standard position. We are told that this point is 6, 0. Well, if I know that this distance is 6, now I know the radius of my circle must be 6. And then I've got the coordinate points for this point right here. Okay, now in this case, I want to find the sine, cosine, and tangent of this standard angle here. All right, and this one's actually a little easier than the problem before. So I'm going to, again, recommend that you pause the video, let you go ahead and work through this, and I will give you the answers in 5, 4, 3, 2, 1. Okay, so once again, sine is going to be y divided by r. So you're going to take the y coordinate, -5.4 divided by 6. Cosine is x over r, so I have that here. And then tangent is y over x. So I'm going to go -5.4 because that's the y coordinate divided by 2.6. And if I plug those into a calculator, I get approximately -0.9 for sine, 0.433 for cosine, and about -2.077 for tangent. Okay, now let's talk real quick about the unit circle. This should just be review since we already kind of talked about it in the last couple of videos. But if, just to refresh you, if you go up here to sine, sine is equal to y divided by r. And of course, in the unit circle, we know r is equal to 1. So if we say y divided by r, and r is equal to 1, this is just y divided by 1, which is y. So the sine value on a unit circle is always just the y coordinate. Same thing for cosine. It's x divided by r, which is really just x over 1. So cosine is always just the x coordinate. And then finally, tangent can't be simplified. Tangent will always be y divided by x. It is the same on the unit circle as it is on any other circle. So I might put like a little star next to that one, just so I remember this one always stays the same. Okay? All right, last problem down here. It says the figure below gives a circle in the xy plane with the center at the origin, angle theta in standard position. Find the value of each expression. Okay, so at this point, you should be able to do this on your own now. So I will give you the answers and then we will end the video. Once again, be careful when you're looking at this picture. It looks like the radius of our circle is 1. All right, because this distance goes all the way out to 1 unit. All right, so I will give you the answers in 3, 2, 1. All right, there are the answers to those. And that is it for this lesson.